Alright, this is Mr. Gillum, and today we're going to start proving parallel lines relationships. And so we're going to use the theorems and we're going to use their converses in our proofs that we learned from truth tables. But the first type of proof I want to do has to do with proving alternate interior angles and why it works. Okay, and they tell us that A is parallel to B and that T is a transversal. So these are in fact parallel. That's what the little arrows signify. Okay. We need to make sure that we are proving angle 4 and angle 7 are congruent. We want to make sure those are congruent, and we also want to do angle 3 and angle 8. Alright, just like that. So that's what we're going for, and those are the two sets of alternate interior angles. So this is the alternate interior angles proof. And so what we're going to do is this. I may have forgotten to put that little, there we go, a little mystery in our lives here. So we're going to start with what they tell us, and I wrote out the word parallel, but there's a little abbreviation for parallel. You might see it like that. It just means parallel. And that's what they give us. They give us two parallel lines and a transversal. And what I'm going to do to start proving that these are actually equal is I'm going to list all the corresponding angles using the corresponding angles postulate. Okay, so anytime I see an angle up there that's corresponding to another, I know that they're equal. So I know that 1 and 8 are congruent. I know 2 and 7, 4 and 5, 3 and 6. I know those are all congruent because they are corresponding angles, and the corresponding angles postulate says they must be congruent. Okay. Then I'm going to look for vertical angles and see if they're congruent. And the reason I'm going this way is because I know there's these 1, 2, 3 RST properties that tell me if I know this is equal to this and this is equal to this, then I can find my final congruency and prove what I'm trying to prove. And so I'm going to list all the vertical angles, and the vertical angles are just the ones across from each other, like that. 1 and 3, 2 and 4, 8 and 6, 7 and 5. Those are my vertical angles, and there's some important ones here. Okay, I'm going to underline that guy right there and that guy right there, and I'm going to underline this one, and I'm going to do it in different colors so you can see which ones I'm referring to. Let's do yellow. This guy's important, and this guy goes with him, and this guy, and this guy. Okay? If I know through the corresponding angles postulate that 4 is congruent to 5, and I also know through the vertical angles that 5 is congruent to 7, then I know through the transitive property that 4 must be congruent to 7. Same way here, if I know that 3 is congruent to 6, and 8 is congruent to 6, then I know 3 must be congruent to 8, and that's a transitive property. And so using some of the other postulates and theorems that we know from the relationships of parallel lines is going to help me to figure out, or to prove, that alternate interior angles are congruent. Okay, and that's the only proof I'm going to do that's like this, but there's going to be some similar ones. We might prove that corresponding angles are congruent, and we're going to use those postulates and theorems that we've been working on lately to do that. So just one example today. Now, the second type of proof that we're going to do is the converse of the theorems that we've been working on, and that's where things are going to get a little tricky. All right, so converses of our theorems are also help to prove that lines are parallel. So these type of proofs, we're going to try to prove something is parallel. The first type of proof, we're trying to prove that angles are congruent using the parallel lines theorems. So if corresponding angles are congruent, then the lines are parallel. Usually we say if the lines are parallel, then the corresponding angles are congruent. So we're just flipping it around. So if angle 1 and angle 8 are congruent, if they just happen to be congruent, then N and P will have to be parallel. Okay, that's what it's saying. If alternate interior angles are congruent, then the lines are parallel. So if I look at alternate interior angles, if they just so happen to be congruent, then I know the line N and P must be parallel. It's just the converses. It's working backwards, and it can be kind of confusing. Alternate exterior angles. So if 1 and 6 happen to be congruent, then you know that N and P will also be parallel. Or if the consecutive integers, the consecutive interior angles are supplements, so like 3 and 7, if they add it to 180 degrees, then you know for sure, without a doubt, that the angles, or the lines N and P will be parallel. All right, so now we got a new proof here, And I'm going to cover that one up so you're not sneaking a look at it. And now we got a new proof. And the difference between this proof and the last proof is that this one is asking us to prove that the lines are parallel. So as soon as you see that they were trying to prove that lines are parallel, you need to be thinking that we're using the converses of other parallel line theorems. Okay? So as soon as you see this guy right here, that tells you that you need to use these fellows right here, the converses. All right? To help you prove that they're parallel. So we're going to start with what's given to us. And it says angle 1 is congruent to angle 3. Okay. Ooh, alternate interior angles. And AC is parallel to BD. So these guys are parallel. All right, it doesn't say anything about line AB and CD, but we can figure it out. So I'm going to start with, I'm going to say angle 2 is congruent to angle 3 because they're corresponding. I know that because these are parallel. 2 and 3 must be equal to each other, or congruent to each other. That's what a corresponding angle is. So we're going to use the corresponding angles postulate. I'm then going to say that angle 1 is congruent to angle 3. This guy and this guy, they are congruent. I can say that because if I know angle 1 is congruent to angle 3, and angle 3 is congruent to angle 2, then through the transitive property, angle 1 must be congruent to angle 3. And so this transitive property is going to be really important because you're going to find multiple relationships that you can find congruencies in, and you're going to be able to shift from one all the way to the end with the transitive property. I know that they must be parallel because if they are alternate interior angles and they are congruent, then the lines must be parallel. And that's the converse of the alternate interior angles theorem. Okay? And these guys would be, let's see here, angle 1 and angle 3 are congruent. They're alternate interior. Therefore, CD and AB must be parallel. So when we're trying to prove parallel lines, you're going to end up with a converse in there somewhere because we have to find multiple relationships of parallel lines. And then finally, the last one, my favorite one. Okay, we are given this shape here. It just looks like a diamond. And it says the angle ABC is congruent to ADC. ABC is congruent to ADC, right there. It also says the angle measures are supplementary of angle A and ABC. This guy and this guy are supplementary. So we're going to prove that these angles are parallel. Sorry, these segments are parallel. We're trying to prove, when we're going forward, we're trying to say that these guys are parallel, but we don't know that yet. Okay, so what we're going to do is we're going to start with our given information. All right, all this information, as we always do. And remember, we're going to work towards our converse. So if we know that they're supplementary, well, I guess before we do anything, we have to change our congruencies into equal signs because we can't do any substitution with congruent signs. We have to have them as equal signs. So the congruent is going to change to an equal sign. That's just the definition of a congruent angle. It means they're equal angle measures. And what I'm going to do is, since it says that angle A and angle ABC equal 180, I know I can just substitute in. And so angle ABC and angle ADC have to add up to 180. So I just plug this guy in right there. And then finally, angle A and angle ADC are supplementary. That's the definition of a supplementary angle. They must equal 180 degrees. And finally, if I'm trying to show that they are parallel, which is AB and CD, if I'm trying to show that they are parallel, I know that my consecutive interior angles theorem says that if those angles are supplementary, then they must be parallel. So it's this guy right here. Okay, if the interior angles are supplementary, it must be parallel lines. All right, so that's it. So once again, if you're proving that lines are parallel, you're going to have to use the converse of the theorems that we've been talking about. And these are just going to take practice, a lot of practice. That's it for today.